In class 12th, I will tell you about the Ampere's circuital law. This is a very important law. With the help of this, we can find the magnetic field due to the currents producing it. So, Ampere gave a law in 1826. In 1826, Andre Ampere gave a very important law which shows the relationship between magnetic field and currents producing it enclosed by a closed loop called Amperian loop. Suppose we are having this loop of any shape. Suppose now currents are passing through it like this one. Some of the currents are passing which are going opposite to it. Let this is suppose I1, this is now I2, and this is now I3. Here suppose we are having a element of length dl, then the magnetic field, this is the magnetic field B. So magnetic field is always in the tangential direction to the Amperian loop. The magnetic field is in tangential direction of Amperian loop that we have considered here. According to Ampere, the line integration of magnetic field along closed loop is equal to the algebraic sum of currents enclosed by loop multiplied by magnetic permeability. So the line integration of magnetic field means this is now line integration. This is now for closed loop B dot dl. This is now line integration of the magnetic field. This is equal to mu naught into summation I. Summation I is what? The algebraic sum of the currents enclosed by the loop. Suppose here we are having the three currents I1, I2 and I3. Some of the currents are going up and some of the currents are coming down. So this summation I will be equal to the algebraic sum of these currents. The currents which are going up, they are taken to be positive, and the currents going down, they are taken to be negative. So this summation I is equal to I1 plus I2 minus I3. This is the Ampere's law. Where summation I is equal to I1 plus I2 plus minus I3. So this is equal to I1 plus I2 minus I3. This is what the meaning of algebraic sum of the currents. Now you can have from here that this integration B upon mu naught into dl is equal to summation I. So this is equal to integration h dot dl is equal to summation I, where this h where h this is equal to B upon mu naught, called the magnetic field, called magnetic field. So this integration h dot dl, this is called the magnetomotive force. This is just like the electromotive force. Integration h dot dl is called magnetomotive force, and this magnetomotive force is equal to the sum of the currents. So the magnetomotive force equal to integration h dot dl, and this is equal to summation I. This means that the unit of magnetic motive force is the ampere. Unit of magneto-motive force is ampere. Ampere. And you can see from here that summation I may be equal to 0. And as such, this integration may be taken to be clockwise or anti-clockwise. When this is taken to be clockwise, it means that the current, the sum of the currents is positive, and they are going in the upward direction of the loop. So we are having this right hand rule. This is now suppose loop in this way, then currents will be in this direction. So these are the positive currents. When we are having the downward currents like this, in this way, then magnetic field will be clockwise, but the sum of the currents will be downward. If summation I is equal to 0, then integration b dot l, this is equal to 0. अगर ये इंटीग्रेशन b dot del equal to 0 है तो इसका पदार्थ मतलब ये नहीं होता है कि that there is no magnetic field. It does not mean that b is equal to 0. So sum of the currents is 0, but magnetic field is not 0. There will exist a magnetic field. So this is what, that when we are having a number of currents, they will produce their own magnetic field. So this is what the relationship that shows the magnetic field produced by the current which are enclosed by the closed loop, enclosed in the closed loop. So each current produces its own magnetic field. So this magnetic field is not 0, but the sum of the currents is 0. So we can say that when this is equal to 0, then magnetic field is not 0. This is not essential. So this is the Ampere's circuital law, and this is very important that we will use to find the magnetic field because of the infinite long current carrying state wire or the state conductor. So thank you very much.